Hello, so today we're going to start talking about the sine rule. But before we do that, I'm just going to mention exact values. Now, you've probably found that when we find sine, cosine, and tangent, they give us exact values, okay? So it's really useful to know some of them without having to calculate them every time. And our tech-free portion of any test or exam is going to rely on that. And it just might make things a bit faster for you. So these are the ones that you are going to need to know. So that's 30 degrees, 45 degrees, 60 degrees, and 90 degrees, but I haven't got that listed here. You'll be expected to know these in methods as well. So if you learn them now, it's going to put you in good stead. And you need to know them for sine, cosine, and tangent of those angles. So there's a little YouTube video there that explains how we got them. And there's a little hand trick video as well to help you remember them. I've watched that, and that's actually a very good trick, which I might start using myself. Okay, let's start with what we're really here to discuss, the sine rule. Now please notice I always say sine, not sin, sine. I've linked a YouTube video there, that's an introductory one. There's another one that I've got up there, which is for the acute instance of the sine rule, which you can watch as well. So there's lots of information out there you can find. So when can we use the sine rule? When either one of these scenarios is given. So we get given a triangle and we get given some things, some knowns and some unknowns. So if we know one side and two angles, we can use the sine rule. If we know two sines and a non-included angle, that is the angle that's not between them. If either of these scenarios are presented to us, we can use the sine rule. In other situations, we have to use some of the other rules that we'll get into slowly through this chapter. Okay, so the sine rule. Side A divided by sine of angle A is equivalent to side B over sine of angle B. It's also equivalent, because there's lots of ratios here, to side C divided by sine of angle C. Now, it's really important that you understand how we've drawn up this triangle. It's really important here. You notice side C is opposite to angle C. Side B is opposite to angle B. Okay, it's always opposite. Okay, so you need to be labeling your triangles really carefully and thinking about it. Now, this rule needs to be in your bound reference. Okay, it absolutely needs to be in your bound reference and easy for you to find. You probably should have a couple of examples of you using it. So here's some worked examples of me using it. So find the unknown length x in the triangle. Okay, so looking at this triangle, I've got that angle. I want to figure out that side, and I've been given that angle, and I've been given that side. So because we've got two sides and one angle, sorry, say that again. We've got two angles and one side. I can then figure out a third side. I can use my sine rule. Okay, so just having a think about this, this is our formula. Now on this worked one, I didn't label in my knowns and unknowns. So that's angle A, side A, angle B, side B. And it is very important that you are using the capital letters and the lowercase letters correctly, so you are not confusing yourself. Lowercase are for sides, uppercase are for angles. Okay? Then I sub in to my formula, my knowns and unknowns. I can transpose that to get an answer of approximately 10.7 is what x is. Okay, find the unknown length x, correct to 2 decimal places. So here I've got 2 angles, one side, and I want to know the other side. Okay, so yes, that does meet the requirements. Now, looking at this, I've got those two, they match, but hang on, I don't have that angle. I don't have that corresponding angle. That's okay, because I can figure that angle out, because all 3 angles have to add up to 180, and that's what I've done there. I figured that angle C is equal to 15 degrees. I've then plugged in my knowns and unknowns, so side X is equivalent to 1.84. Okay, so one more worked example. So for a triangle PQR, find the unknown angle, correct to the nearest degree. P, given little p, side P is 5 centimeters, R equals 7 centimeters, and angle R is 48 degrees. So if we get given this information, the very first thing we do is draw the triangle. We always draw the triangle first, and we're labeling what we know and what we don't know. Okay, here my R is 48 degrees, so opposite it is that side R, which is 7 centimeters. P, side P is 5 centimeters, so I've got to put angle P opposite it. Now we don't know what Q is, but that's okay. Now here I've got 2 sides and the non-included angle. That is the angle that is not between them. So I can figure out what I can use the sine rule here to figure out P. If I'd been given Q, I couldn't. I'd have to figure out side Q and do other things to figure out what angle P is. Okay. Right, so written out my formula, putting my knowns and unknowns. I've transposed it there. I could have used the solve function on my calculator, or to solve for P. So that is closest to 32 degrees. Okay, so I've taken some exam questions from the Further Maths exam where we use this quite a lot. So, question 5 from the 2017 exam, Northern Hemisphere version. The triangle has one side of length 8 centimeters and another side of length 12 centimeters as shown in the diagram. The angles X and Y are also shown. The angle X is such that sine X is equal to 2/5. what is the value of sine y? Have a little think. Did you get it? Okay, so we had to think about our sine rule. 8 over sine y equals 12 over sine x. But we get told sine x is equal to 2 over 5. Okay, so y over sine y is equal to 12 over 2 on 5. And I'm sure most of you will be able to figure that out, that 12 divided by 2 on 5 is the same as 12 times by 5 on 2, which is 60 divided by 2 is equal to 30. So 8 over sine y. So 8 divided by 30 is equal to sine y, and that is the answer. Okay, let's do a couple from our exercise 20.2. This is on page 849 of your textbook. Okay, so question 1. In the triangle ABC, A equals 10, B equals 12, angle B equals 58 degrees. We want to find angle A, C, and side C. Okay, so first off, let's draw this triangle. Remember, it's a non-right angle triangle, so we're not sure what it is. So I'll put 10 there. So that's A. Put that as 58 degrees. That's 12. So that's angle C. Side C. Okay, so let's start thinking about this. The first thing I'm going to do is find A, because that way, I can then knowing that angle, knowing A, I can work out angle C, can't I? Okay. B sine B. I always write out the formula before I get started. Okay, so that's, then I put in my knowns and unknowns. Sine A equals, forgot to label that, didn't I? 12 on sine 58 degrees. So one way you can do this to make the transposition a bit easier is you can flip the both of them. So you can see it just makes the transposition just that little bit easier, although if you are using a CAS calculator you can use the solve. No harm there. Okay, so let's bring up my CAS calculator, and so inverse, so oops, let's trig. So inverse sine of 10 times brackets, fraction, sine 58. I always put in my degrees as a nice little thing, even though I do have my CAS in degree mode, especially if you are doing methods next year where you start using radians. It's a really good little habit to get into to make sure you're always answering that correctly. So control enter, always control enter those. So A is equal to 44.9676. Doesn't say to the nearest. I'm going to put that to the nearest degree, 45 degrees. Remembering that you can also force, with your little book of functions, your menu there, force it to degrees, minutes, seconds, or where's the DD, or decimal degrees. Remembering to hit control equal to get your approximately equal to. So those are all little tips to make sure you're always getting things in the correct formula. So knowing A is 45 degrees. Knowing A is 45 degrees. Okay. C must therefore be equal to 180 degrees. Take 58 plus 45. One reason why I've left A to the nearest whole decimal was that 58 is given to the nearest whole decimal, so I thought that was, the degree of approximation that the question gives, so stick to the same sort of level. So 180, take 58 plus 45 equals 77 degrees. Okay, so knowing that is now 77 degrees, I can then figure out C. So, C over sine 77 degrees. Now I can use either of these, but because I calculated A, I'd prefer to use the angles and things that I didn't calculate. So that's another good habit to get into, is to use as many values that you were given rather than ones you calculated. Okay, so C equals sine 77 degrees times by 12 sine 58 degrees. So C equals, oops, changed back again, sine 77 equals times by fraction 12 over sine 58 and approximately equals to 13.7875. So depending on what the book has said, 14. So that's what I've said there. So always read the question. Whenever I read a question, I always make little notes to myself about what it is. No, I don't write the question down word for word. I draw the diagram. I put in my knowns and unknowns, and then I write out the formula. Okay, and then you want to highlight the answers you are interested in. Now, in the next video, I'm going to talk about the ambiguous case.